In this tutorial, we are going to learn a new data structure known as linked list. So in this tutorial, I am going to cover following points. What is linked list? Array versus linked list. I mean, what's the difference between array and linked list data structure? How we can insert node at the beginning of a linked list. So in this tutorial, we are covering 3 points. So we understand what is linked list and its basic knowledge. Then we will see why we need a linked list and the difference between array and linked list. So let's start with a linked list introduction. So what is linked list? A linked list is a collection of nodes where each nodes contain two parts, data and a pointer to the next node. So what is pointer to the next node? So basically it contains the address. It points to the address of a next node. And in linked list, elements are not stored at contiguous memory location. So in array, when we create an array, so the elements are stored at contiguous memory location. But in linked list, element can be stored anywhere in the memory, and the node which points to the next node, I mean the previous node point to the next node, I mean the memory location of a next node. So let's understand through example. So so this is a node. So basically linked list is a collection of a node. So let's first understand what is a node. So in node, uh, we have two parts. Our data, the first part is stored the data, and the next the next part store the address of the next node address. So so and what is a linked list? Linked list is a collection of nodes. So this is the example of one node. So in linked list we have a collection of nodes. So this is one, and this node points to next node, and similarly this node points to next node. So let's understand through example. So suppose I have four integers, and this is 55, 67, 90 and 34. If I have to represent it through a linked list, how I can represent? So first I need to create a four nodes. So this is first node, this is second node, and this is third node, and this is fourth node. And so remember what I have said, that uh, in a linked list, elements, I mean nodes, are not stored at contiguous memory location. It can be created anywhere in the memory. So suppose the address of this node is 500, the address of this node is 200, so the address of this node is, let's say, 1000. So this is this address, this example is just to illustrate how the linked lists are stored and how it's working. And now let's say this node is stored at 100. So we have these four elements, and now the head pointer points to the first nodes. So it's head, and the first part contains the data. So the data is 55, and this node points to the next node. So this node refers to the address of the next node. So this node knows where the next node is present in a memory. So now the first part contains data. So we have 67, and the second part uh, points to the address of a next node, which is in this case 1000, and in this case the data is 90, and it points to the address of next node. And so the fourth node, the data in fourth node is 34, and it doesn't point anywhere. So the so the next is null. Null means it does not point anywhere. So it's the end of a linked list. So we start from here, then the first node points to the second points to third, and then third points to fourth, and after fourth we don't have any element or any node in a linked list, so it points to null. It means it's the end of a linked list. So, and if these elements, if we have to store these elements in an array, then how we can do it? So we just create an array of size 4, and we have the contiguous memory location, and in which we point 55, then 67, then 90, and then 34. So let's say the address of first index is 200, then the address of second is 204. Let's say an integer uh, is of 4 byte, then add 4 to it, then 208, and add 4 to it, it is 212. So this is the case of array, and this is how the linked list. Now let's say so this is now let's see the difference between array and a linked list. So I'm just removing this, and let's move it to, so these are the 4 point, and let's see let's discuss the difference between array and linked list. So fixed size, so when we create an array, so it's a fixed size. If we need more element, then we need to create another array which is of double the length of the previous array, and we copy first the elements of this array into another array, and then we can store a new element. But in case of a linked list, so the memory, I mean, so we at the time of creation we don't specify the memory. So suppose if we store 3 element and later we need to store 2 more element, we can store them. We don't need to create another linked list in which we copy the element of previous linked list into a new linked list, and then we add 2 more elements. So this now let's move to contiguous memory location. So in array, element are stored in contiguous memory location, which I have explained to you, and in linked list, new element can be stored anywhere in the memory. So now let's see the insertion and deletion parts. So in case of array, so let's say suppose I have an array of size 5, and 1, 2, 3, and 4. And now let's say I have 1, 2, 5, and 7 element, and I have to insert an element at index 2. Then what I need to do, I need to first create a space. And how I can create in space, I just 1, 2, and let's say the new element is 4. I inserted element 4, and then I moved 7 to one place, I mean at that index, and 5 at that index. So I have created a space for a new element, and then I can insert an element. Similarly, if I need to delete an element, so let's say I need to delete this 2, then after deleting we need to resize the array element. So if I delete them, then I need to shift an element towards left, so 4 here, then 5 here, and then 7, and then this space is left vacant. So insertion and deletion in an array takes O of n time. But in case of linked list, so now let's suppose this is the case of linked list. So I have one node which points to next node, and I need to insert an element. Then what I need to do, I need to create a node, and let's say I need to create one node, and the first part contains the data, let's say anything 7, and if I need to insert it anywhere, I just need to, let's suppose I just need to points the address of the next node. So no need to traverse the complete linked list for the insertion and shift, I mean shift all the previous element to next indexes. I mean there is no concept of indexes in a linked list. So um, we can create a node and we can point to what to the next node, and the creation is done. Similarly, in case of deletion, we just whatever, suppose I need to delete this node, so this node points to the next node. So if I delete this node, just remove this node and points null to it. So no need to shift the, I mean previous elements after deletion of a node. So insertion and deletion in a linked list is much easier as compared to array. Let's move to next point, and the next point is in case of array, value can be accessed directly through index. So yes, so in array uh, elements are stored at contiguous memory location, so we can directly access it by specifying the index. So suppose A is an array, I can directly access element by specifying its index like this. So I have to get the value present at second index, then I just need to put A2 and I get the value of present at that index. But in case of array, there is no concept of index. Linked list only supports sequential traversal, so sequential access. So we need to traverse a linked list to get the value. So this is the basic difference between the array and linked list. And now let's see the code part, and in this tutorial I'll explain how we can insert a node at the beginning of a linked list. So let's move to that part. So this is linked list class. Before that, let's see the node part. So I have explained it to you that a linked list is a collection of node, and in linked list a node has two parts. One is data part and one is pointer to next node. So this is data and other is a pointer to next node, so it points to next node. So we have a node class in which we have two attributes. First is data and other is pointer to next node, and it is of type node as it points to the other node. So this is a node class in which we have two attribute, data and pointer to next node. And now let's move to the coding section. So I have declared a head pointer here, and whenever we create an object of linked list class, then initial value of head, initially head will not point to any node, so it's null here. And so let's start with main method. So I have created a linked list object of linked list and inserted 4 5 6. So the output will be 6, then 5, then 4, and 4 will points to null. Let's see how it's working. So in insert at head, what I'm doing is, if head is not point to any node, then the node we are creating is the first node, so head pointer points to that node. So here we are creating a node. So let's suppose the first value is 4. So no node is present. So head we create a node, and so let's understand through an example. So right now the pointer head points to null, so it doesn't point to anywhere. And in this step what we are doing is we have created one node which has value 4 and it points to null, and the head will points to this node. So this is what happens when the first node is inserted 4. After that, when a new node is inserted, so we create a node. So next value is 5. We create a node 5 which initially points to null. Then we change its pointer and we say point to this node 4, and 4 is already pointed to null, and we point head here. So now the head will points to this node 5, I mean this node, new node, as we are inserting node at a head, and this will points to 4 and it will points to null. So see the code. So if head is not null, I mean one node is already present and head points to that node, then we created new node. So let's suppose 5, uh, so the next node is 5, and the pointer to that node will points to head. So head is already pointed to 4. Now this pointer will points to the previous node which is 4, and then the head will points to the new node. So this will be like this: 5, and it will be points to 4, and it will points to null, and head will be there. So similarly, when the next node come which is 6, so node 6 will create here, and the next pointer to 6 will points to this 5, and the head will points to 6. So this 3 line does this thing. So now once the linked list is created, so let's move to the print part. So we already discussed that if we need any element from a linked list, we need to traverse the linked list. So we have this linked list, this head, and the first element is 6. This points to 5, and this points to 4, and 4 doesn't point any node, so 4 is null. So when I'm traversing this linked list, so I'm checking the condition if temp is not equal to null, I mean temp is pointing to some other node, then I'm printing the data. So let's start from head. So the value of head is assigned to temp, then temp is not equal to null, then I'm printing. So in this case the first node is, the value of first node is 6, then the temp will point to next node, in this case the 5, then again it is not null, so 5 is printed, then it points to next node which is 4, so 4 is printed, and then temp will point to null, and this time when it points to null, this condition will be false. So we printed 654. So this is how this code works, and let's run this code. See the output 654. So in this tutorial we have learned about linked list. We have seen the difference between array and linked list, and we also saw how we can insert node at the beginning of a linked list. So I hope you learned linked list and uh, all the basic concept of a linked list uh, got clear. So if you're still facing any difficulty, please let me know through your comments. If you have any doubt, please ask me through the comment section. And for more such programming video, you can subscribe our YouTube channel. You can visit our website, which is webrewrite.com. And that's it for this video. Thanks for watching this video.